So you just got your brand new heat trace system installed. Now it's time for owner's training, coming up next. Hello, my name is Dashawn. I'm with the Prentice company and I represent nVent Thermal Management, which was formerly Pentair Thermal Management. I'll be doing the owner's training for your brand new Raychem heat trace system. Before we get into any of that, let's first talk about the agenda. First of all, we're going to go over self-regulating heat trace, what it is and how does it work. Next, we'll go over a basic heat trace design coupled with the components for the heat trace system. Then we'll talk about the controller that you have on site. We'll go over the wiring, then the programming, and then finally how to clear any alarms. And then I'll throw in a couple nuggets on troubleshooting and what you should look for. We'll wrap everything up by going over the warranty for the heat trace system. So let's begin. So there are two basic types of heat trace. You have self-regulating heat trace and you also have constant wattage heat trace. Now you don't have constant wattage heat trace on site, so we're not going to really get too much into that. However, I would like to explain that constant wattage heat trace is as the name applies. When you apply a voltage to the heating cable, essentially it's going to stay the same heat output throughout. So if you have a cable that's, say for instance, 60 watts per foot, then once you energize it electrically, it'll stay 60 watts per foot throughout. Therefore, you can't really touch or cross it, or else it'll continue to heat in that area and then it'll eventually burn itself out. But you don't have that on site. What you have on site is self-regulating heat trace. Now, I have a short video, it's about 1 minute long, that I want you to see. And then I'll come back and explain self-regulating heat trace a little bit further.
Raychem self-regulating heating cables automatically adjust their power output to compensate for temperature changes. The outer jacket, braid, and inner jacket provide mechanical, chemical, and electrical protection. But the magic happens in the conductive core that surrounds the two parallel conductors. As the ambient temperature drops, the core contracts microscopically, and the number of electrical paths through the core increases. More heat is produced. Conversely, as the ambient temperature rises, the core expands and has fewer electrical paths. Less heat is produced. At a certain temperature, almost all electrical paths are disrupted and power output is close to zero. A self-regulating heating cable adjusts its power output along its entire length. That's what makes it a safe and reliable solution for many applications.
So in this video, you learned about self-regulating heat trace, that depending on the ambient temperature around the cable will self-regulate, essentially go up or down depending on what that temperature is. So let's explain this a little bit further. Usually I like to use this example. Let's say for instance, you're at a party and the self-regulating heat trace, they have two bus wires on the outside. Now, let's say for instance, you're at a party and in that room that you're sitting in, you have two walls on the outside. Let's take that as our bus wires. Now, for our electrical pathways or our molecules in between the two bus wires, we're going to use as people. So, generally speaking, and this is a very simplistic example of how self-regulating heat trace works, but when people get cold, they generally like to huddle together to produce more heat. Once it gets too warm, they basically separate, causing the temperature to decrease. And essentially, that's how self-regulating heat trace works. When the temperatures get real cold, then the heat trace will produce more heat. When it gets too hot, then it'll reduce the heat. And that's as simple as it gets as far as self-regulating heat trace. Now, self-regulating heat trace has different wattages. We have 5-watt cable, we have 8-watt cable, and we have 12-watt cable, and etc. So in this case, in your facility, you have 8-watt cable. So what does that mean? Well, basically what it means is 8 watts per foot is based on 50 degrees Fahrenheit. So if the cable is experiencing 15 degrees Fahrenheit around that cable, then you should experience around 8 watts per foot output on your heat trace. Now, because it's self-regulating, if the temperature around it is higher than 50 degrees Fahrenheit, then you should expect the heating output to be a little less than 8 watts per foot. Say for instance 7.2 or 7.5 watts per foot. On the other hand, if it's colder than 50 degrees Fahrenheit, let's say for instance 40 degrees Fahrenheit, then you should expect a little bit higher than 8 watts per foot. So say for instance like 8.2 watts per foot or 8.4 watts per foot. Now that's not indefinite. It is a maximum to how much the heating cable is going to put out. However, that gives you a good example of how the 8 watts per foot or any type of heat trace works in that situation. So now let me throw out a trivia question for you. So we learned about constant wattage heat trace, just a brief summary of that. Now remember I said that you can't touch or cross it, right? So now my question is, can you touch or cross self-regulating heat trace? Well, if you answer yes, you'll be absolutely correct. Why? Well, because if you touch or cross self-regulating heat trace, it's based on the ambient temperature around it. So if it gets too hot, then it'll start regulating itself back down. That's why you could touch or cross self-regulating heat trace, but not constant wattage heat trace. So now let's go over a basic heat trace design. Basic heat trace design starts with always a breaker. So out of your electrical distribution panel, you're going to have one circuit breaker, and you're going to run regular electrical wire out to, in this case, your controller. You have in one power or voltage, let's say for instance 120 volt or 208 volt. Into the controller, you're going to run the same voltage out of that controller. So it's basically like a pass-through. Now, once you leave the controller, you're going to go to the first component, which is a power connection kit. And essentially, it's a transition between your regular electrical wire to your heat trace. Out of that, you're going to run your heat trace along the pipe. Now, we usually don't spiral the heat trace cable unless the owner really wants it. But heating wise, it really doesn't make a difference. So we usually recommend running parallel down the pipe, and we mount the heat trace to the pipe using tape. Now, depending on what type of pipe you have, whether it's metallic pipe, we usually use a fiberglass tape. If it's a non-metallic pipe, we'll use aluminum tape. So you do that all the way down till you get to the end of the heat trace run. At the end of the heat trace run, you'll have an end seal. So now let's go over the components. So first of all, you're going to have a controller. What you have on site is a C910 controller. It's a single circuit controller rated up to 30 amps. And we'll talk about that more in depth a little bit later. Now, telling the controller when to cut on and off is called an RTD. Basically, it's a resistance thermistor. And it just tells the set point of the controller when it gets to that set point to cut on. And then when it gets past that set point to cut off. Next, you're going to have a power connection kit. In this case, your power connection kit is called a JBS 100A. It's one circuit in and one heat trace cable out of it. Then you're going to run your heat trace, which is, in your case, a 8-watt cable rated at 208 volt to 277 volt. It's called the BTV2CR cable. Next, you're going to have fiberglass tape, since your your pipe is metal. And then at the end, you're going to have an end seal. Now, after all of that is complete, the insulator will come by, insulate the pipe over the heat trace. And then your final step is to use the ETL, which is your labels. And that's basically a warning label telling everybody around that is heat trace underneath this insulation. So don't cut the pipe. And essentially, that's all your components. And also, that's a basic design for your electrical system, your electrical heat trace system. Now, let's get into the actual controller. All right, so for the controller, I have a controller that's sitting next to me that we're going to actually access and get into. Now, for this controller, like I said before, it's a C910 controller. Now, this controller goes from 100 volts all the way up to 277 max voltage. And it is for one circuit, and that circuit can go up to 30 amps. Now, this particular controller, it monitors several features. One thing it monitors is your actual temperature. It also monitors current, and it monitors ground fault. So, and also alarms as well. And we'll talk about that a little bit later. So now let's get into it, and we're going to talk about how to wire this control panel, and then we'll go from there. So let's come on over. Alrighty, so this is a C910 controller. Now, when you see the C910 controller, you'll see that you have two clips up top and bottom, and essentially you unhook those clips to open up the door. Okay, when you open up the door, you have a controller. Now, usually it's off, so let me cut it off. So you'll see it basically like this. Now, you have a protective cover here that's protecting your electricity for touching any of the terminals. Now, what you'll do is you'll take basically a Phillips screwdriver, and you have two screws on either side that you'll unloosen. Once you unloosen those two screws, you can lift up the cover and take it off and keep this for safekeeping. Next, we'll go from left to right. So these right here are your power inputs from your electrical breaker. So now for these inputs, remember I said that your heat trace controller goes from 100 volts all the way up to 277 volts. So when you look at this, you'll see your line in and your line out. I'm sorry, your line in and either your neutral or line number 2. So if this is 120 volts that you're using coming in, you'll have your hot wire for your first terminal, and then your second terminal would be for a neutral. Next, let's pass by the 208 volt right now, and let's talk about 240 volt. Now, when you have 240 volt, usually you'll have just two hot wires and a ground, and then also, you'll have your two hot wires and a ground. So you'll put your one hot wire here, your second hot wire up under this terminal, and then you'll install your ground down below. Now for your 277 volt, you'll do your hot wire and then your neutral and then your ground below. Now let's talk about the 208 volt. Now for 208 volt, usually you'll have two hots, a neutral, and a ground. But in this case, you're going to wire your 208 volt just like you would 240 volt. So you'll run your two hot wires. It's no need to pull a neutral into this panel, and you'll run your ground over here, and that'll be your 208 volt system for heat trace. Now let's talk about going out to your loads. your heat trace loads. With that, whenever you bring power in here, whether if it's 120 volts, then you will have the same output. You can't run 120 volts in and expect 208 to go out to the controller. The heat trace. So whatever you have in is what you're going to have going out. Okay. So just like we said before, 120 volt, you have your hot wire here, you have your neutral here. For 208 volt, you'll have your 2 hot wires, and then you'll run your ground down below. For 240 volt, you'll do the same thing. And then for 277 volt, you'll have your hot and neutral, and then you'll run your ground. And that goes out to your heat trace. Now, let's slide down. Bypass this right here, these wires right here, because they basically control wires. We're going to go to the RTD. Remember I said that we have RTD inputs here. Now, you can have up to 2 RTD inputs for a C910 controller. Now, a lot of times we only use 1. However, it's possible if you want to use multiple ones, which are up to 2. So in this case, you have a ambient sensing RTD. Now, ambient sensing RTD is essentially this right here that's shown here. And it's a 3-wire RTD system. And usually, if you want to extend these wires, we usually recommend a 18-3 conductor. Now, for these wires here, the bottom is basically for RTD number 1. And we have 3 wires here. You have your common, and then you have 2 of the same color wires, which is your sensing and line, I believe. Now, if you wanted 2 RTDs, you could install the second one up here. Okay? And essentially, that tells the controller when to cut on and off. And this RTD is necessary in order for this heat trace not to go on alarm and work correctly. And essentially, that is your wiring, really, that all needs to be done for your system. Now, let's talk a little bit about what alarm features it has, or monitoring. So now for monitoring, you can have a dry contact here, which is 12 and 13, and it's just basically 2 wires going back to your BMS system just to tell you when this is an alarm. We also have a feature where you can have a proto node that communicates to your BMS system. So what you'll do is you'll run these wires out to a proto node, and then that proto node will communicate and translate if you have BATnet or a different type of Modbus. Now, this is a Modbus right here, but this can communicate with a BATnet system via a proto node translator, essentially. And essentially, that is all of your wiring, your hard wiring that you need to do for this particular controller. Now, let's get into the programming. For programming, I'm just going to put this cover back on just to be safe. Now I'm going to energize this panel. When you first energize the panel, it's going to start up and do a startup menu. When it starts up, it's going to usually run a test, and that test shows an output here. Now this is going to go off if it's not up to temperature. So now you have a rolling screen here. What this shows is you have your regular temperature, you have your set point temperature, which is SP, and then you have your I, which is your amps that is drawing. Okay, so when it first starts up, this is what you're going to see. All right, now let's talk about programming. Anytime you program this, in order to change anything in this menu, you have to hit shift here, which is to the far left. You hit that shift button. When you do that, this light comes on above it. When you see this light, you know that this is the area that you want to be in. So you hit shift And then let's go all the way over to the right here, and it says config or enter. We're going to hit this. You're going to see control set point or setup. Now, this particular controller that I have is a demo unit, so the programming is going to be slightly different from the one that you have on site. The menus are the same, except for how do you get to the menus might be a little different. So what I'll just say is this is where you need to go in order to change XYZ. So let's start. So now we want to make sure that this is over the config area here, or the enter button. What we want to first do is change the set point temperature. Now this is a temperature controlled area that I'm in right now, so it's about 66 degrees. Now in your area, what I usually like to do is set the temperature or the set point between 45 and maybe 38 degrees Fahrenheit. So anywhere in between there, but it's up to you, whatever you need to set it at. Now, since you have an ambient sensing thermostat, what I like to do is set it, like I said, maybe at 42 degrees. However, in this case, in order to energize this, I'm going to have to set it higher. So what I'm going to do is I'm going to set this up to maybe 80 degrees Fahrenheit. In order to do that, I have the rolling screen here, with this is accessed here. What I'll do is hit enter, and you'll see it blinking. When you see this blinking, that means that you can change the set points. So I'm going to take this all the way up to 80 degrees Fahrenheit. And then once I get it up to 80 degrees Fahrenheit, what I'll do is I'm going to hit enter. And then that means that it sets whatever you want it at. This is the set point now. It's 80 degrees, and you can see it here. Once it starts flashing, then you know you set it correctly. As you can see here, the output light is on. That means that the heat trace is on here. Now, the next thing that I like to change is several things. So the first thing I like to change is the temperature. Now, when you get your particular unit brand new, the default is 40 degrees Fahrenheit. Now, 40 degrees Fahrenheit might be fine for you, so you may not have to change it. So the things that I like to change on the menu is the temperature. I also like to look at the TS1 low alarm, and also the low load alarm. Those are very important as well. So let's talk about the TS1 alarm. Like I said before, your menu is going to be a little bit different on how to find it. So I'm going to go down to where I can find mine and access it. Okay, so what I need you to do is go down to, you get to TS1 enable or disable. So when you go down to TS1 enable, if you have an ambient RTD, what I like to do is, and that's the only one you have, the only RTD you have, what I like to do is disable the low temperature alarm. Why would I do that? Well, when at this set point here, let's say for instance you have a set point of 40 degrees Fahrenheit. Well, when it gets 40 degrees, the heat trace is going to turn on. So your heat trace is on, is drawing the output, but as the temperature goes down, because it's only monitoring the ambient temperature around it, so as the temperature goes down, it can reach your set point or your low temperature, and it'll go into an alarm. But it's not necessary to have it on because of the fact that you already know that the heat trace is on. So a lot of times I would like to disable that. Now, if you had two RTDs, like say for instance a line sensing RTD and then an ambient RTD, what I would like to do is put the alarm, the low temperature alarm, on the line sensing RTD. and then I'll disable the ambient sensing RTD. So in this case, you only have the ambient. So personally, I would like to just disable that. And what you'll do is go over here down to low TS1. You see enable right here. You hit enter, you'll see it blinking, and you'll go over here to disable, and then you'll hit enter. Now the TS1 is disabled. Okay. If you go further down, you'll see low TS2. Now usually factory has that as a factory default disabled, and since you don't have a second RTD, leave it alone. You can just leave that alone. Now the next thing I like to change is the low temperature, the low current alarm. Now I'll show you how to do that now. I didn't mention this before, but anytime you get into a system here or a menu and you want to get back out, you could hit the back button here. It says monitor or back. Just hit it once and then you'll go back to your main menu here. And then you could just hit down and go down further. Now I want you to go down and find switch control mode. The switch control mode, I like to usually use deadband. It may be already factory default deadband, so you may not have to change it. But in this case, I'll show you how to change it. So basically, let me explain deadband. Deadband we'll have either a 3 or 5 degree deadband on our heat trace. And essentially what that means is, like say for instance, it's a 45 degree set point. So at 45 degrees, the heat trace is going to energize and cut on. Now, to prevent it going from 46 degrees, 45 degrees, and it cuts back on and off, we'll have a deadband in between. That deadband means that it's going to, at 45 degrees, it'll cut on. At 46 degrees, it'll still be on, all the way up to it gets to 50 degrees if it's a 5 degree deadband. 50 degrees, it'll shut off. And basically that prevents the controller from cutting on and off like an electrical mechanical relay does. So it can prevent that from cutting on and off a lot of times. So basically that's what I like to do. So let's switch the switch control mode to deadband. Now yours should be already default as deadband 5 degrees Fahrenheit. So you should be fine, but if you have to change it, this is how you do it. Switch control mode, and it'll be deadband. You click that, it starts blinking. You'll go down to deadband if you need to. They have other features like proportional and things of that nature, proportional ambient and things of that nature, but I like to use deadband. So in order to lock it in, make sure you hit enter, it'll stop blinking and it'll say deadband mode. Go down 1 and you'll see what the deadband temperature is. It's 5 degrees. If you need to change it, you always hit enter, it'll blink. You can go up or down to change it. And then lock it in, you hit enter again. Now to get back out of this, you hit back 1 time and you're in the main menu again. Okay? So now what I'm going to do is go past switch control mode, and I want to go down to the alarm, the auto cycle. Now, auto cycle is going to be disabled from the factory. So now what I like to do is use auto cycle. Well, what is auto cycle? Auto cycle basically tells the controller to do a test on your heat trace system at intervals. Now, what I like to usually do is set it for every 24 hours. So I'm going to show you how to enable this auto cycle, and then I'll tell you how to, or show you how to change the setting on that. So let's go. So now I want you to go down to auto cycle, and then you'll probably see disable, but this is enable. What you want to do is click it, go down to, it'll be on disable probably, so you just go up to enable and then lock it in. Now it's on enable, go down 1 and you'll see the cycles, the intervals, basically. Now, yours will be 8 hours, every 8 hours. What I like to do is usually use 24 hours. So basically you just go up and down or up all the way to 24 is all set. Now, there was one other feature that I wanted to talk about, and that would be essentially your low load. So let's go up to other. For me, is other. But what I want you to do is go to low load, and it'll either be enabled, it'll probably be enabled, and mine is disabled right now. But yours will be enabled at 1 amps. Now, here's the thing. So with this feature, what I like to do is, if I know that after 10 minutes of being on, the heat trace is going to draw over 5 amps, or maybe, say for instance, over 2 amps, then I'll leave the default alone. So it'll be 1 amps for an amp draw alarm. Now, well, let me go back and basically explain what this means. So the low amperage means that it'll get an alarm at 1 amp. So if the heat trace is only drawing 1 amp, then the controller will go into an alarm. All right. So now what I'm saying is, if you start up the heat trace and leave it on for like maybe 10 minutes or so, and the heat trace is drawing, let's say for instance, more than 2 amps, then what I would do is I'll just leave the 1 by itself. If you have a shorter run and your heat trace is hovering around 1, between 1 and maybe 0.9 amps, what I would do is I would take this down to either 0.7 amps or 0.5 amps to avoid any nuisance tripping, or not tripping, but nuisance alarms. So let me show you how to do that. So essentially you're going to low load, and yours will be enabled. So I'm not going to enable it yet. I'm just going to go down to, I will enable it. Okay, so now I enabled this. I'm going to go down to, I didn't want to enable it because I knew it was going to go an alarm, and I'll explain that a little bit later. So now we have a low load, and it says 0.3 on this controller here. Now the reason why I didn't want to enable it, but I had to, is to access the low load set point. So now the reason why it's an alarm right now is because I don't have a load on this heat trace, but the output light is on. But I wanted to get into that during the alarms, okay? So essentially, you change this the same way that you would any other thing. You would go in, you would hit enter, and you can go up or down as you will. Now, if you have a really, really short circuit length over your heat trace, a short run of heat trace, I would basically just disable this feature because you don't want any nuisance alarms, essentially. All right. Now, since we've already put the panel in an alarm, let's talk about alarms. Now, in order to access any point of this alarm, what you want to do is, first of all, you have to clear the alarm or whatever's causing the alarm first. So in this case, this alarm is not going to clear until I fix whatever the issue is. So in order to look at an alarm, what you want to do is hit the shift button first. You'll see the light appear. The next button you want to hit is the alarm or test button. And you'll click on that, and it'll show you what the actual alarm is. In this case, it's a low load alarm. So again, like I said before, you have to clear it first. It's not going to clear, but I'll show you how to clear this, or try to clear it. So basically, you just want to keep hitting enter, and it'll ask you to reset. Yes, you hit enter again. if you caught that, it said no alarms, and right before it said no alarms, it went back into alarm because it wasn't clear. So what I'm going to do is I'm going to disable the low load alarm first. So let me go back into here, and I am going to disable this alarm feature, and then the alarm went off automatically. Okay, so now let me show you another alarm, and then what I'll do is I'll show you what that means. So we've already seen the low load alarm. Now let's see the low TS, or the alarm of a TS1 failure or a RTD failure. So what I'm going to do first to be safe is I'm going to cut this off. Okay. We'll cut that off first. We'll take this off here. Set that to the side. Then I'm going to take, oops, it's back on again, huh? Okay. All right, I'm going to take my screwdriver and I'm going to disconnect one of the wires here. Then I'm going to cut it back on and give it a little bit before it goes right back into an alarm. Now it's back into an alarm. It says a TS1 failure, if you caught that. Yep, T failed. So to access it again, we're going to hit Shift and then Test, and it says right here TS1 fails. Then you go down, that'll tell you the second alarm, which is a CTL TS fail. Essentially that deals with the failure of the RTD. You're going to get two different types of alarms. Go down one more and it says N. This means that you don't have any other issues or any other alarms in the system. Now remember what I said, in order to clear the alarms, you're going to have to fix whatever the problem is. So let's do that now. Let's cut this back off. And I'm going to take my screwdriver and I'm going to reconnect this back up. Oops. It's difficult doing this with one hand here. Alrighty, so that's in there. Now I'm going to re-energize this, cut it back on, and actually, because it's already fixed and it was off, the alarm went back off again. But I showed you how to clear it before, which basically when you hit Shift and Test, you're going to keep hitting Enter until it clears the alarm. And essentially that's how you clear the alarms. Now the other type of alarm that you may experience, and hopefully you don't, is your ground fault alarm. Now your ground fault has a 20 milliamp alarm. And let me just go on and show you. So your ground fault has high GFI at 20 milliamps here. Now that means that if the ground fault gets to 20 milliamps, it'll alarm. It won't shut the circuit off, but it will alarm. Your next one is your GFI trip. That is at 30 milliamps. So if it gets to 30 milliamps, then the heat trace will go and alarm, and actually this controller will trip out right then. So essentially, in order to clear this, you're going to have to fix whatever the issue is, and then you can go and clear the alarm. All right. Now let's talk a little bit about any troubleshooting. So when you have an issue, especially like a ground fault Or like say for instance, if you come to the panel and it was a low temperature alarm and you have an ambient sensing thermostat, then it's not a big deal, because what happened was your TS1 or TS2 was enabled and your temperature just dropped down. It doesn't mean that your heat trace is not working correctly. So now if you have a low load, that could be an issue. But like I said before, if your loads were hovering around 1 amps or so, and your if your output is around 1 amps and it drops a little bit below that, you're going to get an alarm. So that's not necessarily an issue either. You could either disable it or lower the low current alarm. But if you have a ground fault, that's a different issue. That means that somehow or another you have an issue. Whether or not that, what I like to do is first I'll look at the power connection kit to make sure that water is not getting into the power connection kit. Okay, sometimes it's water, sometimes it's condensation that you may get. Or you'll look at the end seal, and if it's when you first initially start it up, if you're getting a ground fault, look at the end seal to make sure that none of the wires are touching or crossing or anything like that. Then if it's been on and working for an extended period of time, what I would do is make sure that nobody was doing any work around the pipe or the heat trace within the last couple days or the day or so. And also you want to check to make sure there was no damage to the pipe or the heat trace. So those are the areas that I will look in if you have a ground fault issue, and those are for troubleshooting. Now, if everything looks correct, then what I would do is I'll leave my number and contact information at the end of this video. You can always contact me, or you can contact nVent Thermal Management Technical Support, and they can try to walk you through it as well. But I'll leave that information at the end of this video. So that's basically the pointers that I would use for troubleshooting. Now let's look at finally the warranty. So nVent Thermal Management or Raychem products have a 2-year warranty on all parts and also heat trace standard. Okay, I think most of our competition only has a 1-year standard warranty, and that's the day of purchase. Now, you can also get an extended warranty if the system is tested, mega tested, and then you register your information to nVent Thermal Management. Then you can get a 10-year warranty on the cable, and basically if the cable goes bad, then and it's a problem or a defect in the actual cable, then nVent Thermal Management will replace the actual cable. Now that doesn't include any labor or anything like that. It'd just be replacement of the actual cable itself. So that's basically the warranty. 2-year standard warranty on all parts and also heat trace or components and heat trace. And then a 10-year additional warranty if you register with nVent Thermal Management, and that is just replacement of the actual cable if it's showed to be in default or a default in the cable. And essentially that is the end of the owner's training. So like I said before, I'm going to leave my information, my contact information down below at the end of this video, and I'll leave nVent Thermal Management's information as well. And on behalf of myself, which is Dashawn, and the Prentice company, we welcome you as a new customer, and we thank you for your purchase. Thanks a lot. Bye-bye.